Hello all, today we will be discussing the solutions for assignment 9. Question 1. What is the delay of the critical path of the circuit shown in figure 1? So, to determine the critical path, you need to go over, list down all the paths and then, find out which is the path which has the maximum delay. The path from an input to an output with the maximum delay is known as the critical path. So I have listed down, all of the paths here, P1 to N3 to N4 to PO1. So which is PI1 to, let's say, N3 to N4 to PO1. This could be one path. So there are a number of, there are these many number of paths. And if you look at this path, right, which is PI to I1 to I2 to N1 to N4 to PO1, you have a delay of 6, right? Uh, Therefore, the total, this is the critical path. The delay of the critical path is 6. Yes. Moving on to question number 2. The critical path traverses through the gates in figure 1 in which of the following orders? So, in the earlier discussion, we have, looked at the order in which it does go through, which is, I1, I2, N1, N4, and PO1. It's with till N4, right? Basically, and PO1 is the output and PI1 is the input node, and these are the gates. So we're looking at the gates. Yeah, that's question number 2. Question 3. What is the delay of the contamination path? Uh, that is the path with the least delay for the circuit shown in figure 2. So as you can see that all the other paths, right? This, let's say this, etc., have multiple delays associated with it. If you look at this path, which is P2 to N4 to PO2, which is traversing through just one gate with a delay of 1, that is the contamination path or the path with the least delay. Okay. Question number 4. The contamination path traverses through the gates in figure 2 in which of the following order? So we've discussed that it is N4, right? N4 is the gate it traverses through. Moving forward, what is the propagation delay of a 64-bit triple adder given the delay of carry and sum are 3 and 2 units respectively? So in this case, the 64-bit adder, ripples through all the stages like this, where you have your carry rippling and this is your sum output. But the ripple through the carry is what determines your final this thing. And since the carry delay is greater than the sum delay as pointed out, this path that you can see uh, from here to here, that is 64 times t carry, that's equal to 192 is the answer. Question number 6. Which of the following inputs is timing critical in the full adder whose sum output is the most significant bit of the adder in an 8-bit ripple adder, carry adder? So when we say, which is the critical input, right? Since, a ripple adder is propagating through the ripple through the carry path as shown even in this diagram here. Therefore, you need to optimize for C in, which is your carry in to carry out, because the carry in is what, is your last arriving signal. Therefore, that needs to be fast, and therefore, the timing critical signal is your C in. Okay. Question number 7. 512-bit carry skip adder is implemented uh, using blocks of 4 bits, 8 bits, 16 bits, and 32 bits. Assuming TGP equal to so much, T bypass so much is carry and sum. The critical path delays of cases A, B, C, D are. So, you can go ahead and refer to the lecture for what is a carry skip adder. And the formula for calculating the carry skip adder's delay is given by this formula, right? So you can go ahead and plug in the values for N, M, and all the parameters that are given here, you will notice that you will end up with this as your answer, right? So I'll just give a minute for you guys to look at the working here for A, B, C, D. Yeah. So 146, 98, 98, and 146 is the answer, right? Moving forward, question number 8. From question 7, what can you infer as the optimal ripple block bit precision with the least critical path delay for a 512 bit, carry skip pattern? So from the previous question, you can see that the optimal delay for both, the delay for both 8 and 16 are at 98. So both of these would be, correct answers. Question number 9, a 512-bit carry skip pattern is implemented using so much with these values. What is the critical path delays? So, carry select adder is what is asked here. So again, you can go back to the lecture and find out the formula for, your carry select adder, which turns out to be this, with this being the fundamental data that is provided to you. And again, if you plug in the values, this is what you will end up getting. And your answers are 141, 85, 69, and 85. So please do go back and look at this for more information. So you can just look at how to plug these values in like this, and you'll get these values: 141, 85, 69, and 85. The following question asks you again from question number 9, which is the best possible combination. If you see 69, the delay 69 is the minimum. That is, for m equal to 16, you're getting the best value. So 16-bit blocks is the correct answer for question 10. Question 11 and 12. So one way to approach question 11 and 12 is to look at giving the values of A, B, and C in such as given in the question. The other way to look at it is also you can uh, write down what is the values before and after. For example, A, B, C, I was 1, 1, 1 before, and after it is 1, 1, 0. So the C naught and S is 1, 1 before and 1, 0 later. So there is no change in C naught, but there is a change in S from 1 to 0, meaning S bar changes from 0 to 1, right? Uh, so the satisfying options are S bar crosses VD by 2 before C bar does. C bar does not even cross, so doesn't matter. So S bar does cross VDD by 2, and C bar does not cross the VDD by 2 in response to the change of the input. So C bar remains to be 0. C bar is 0 since C naught is 1, right? Similarly, again for question number 12, you can write down what is the values before, which is 0, 0, 0, gives you 0, 0. What is the value after, which is 0 and 1. So the C bar again does not change, and the S bar, or the S changes from 0 to 1, or S bar changes from 1 to 0, right? So the C bar does not change, and S bar crosses VDD by 2 before C bar does. Therefore, these are your answers. If you have any more doubts regarding this assignment, please do contact me in the discussion forum. Thank you very much.